Hello, everybody, and welcome to another episode of EOXS's Stories on Steel. This is a steel industry podcast featuring the big names of the business and the advice/stories they've accrued over their years as insiders. Steel has been a vital component in American life for well over a century, and the men and women who've helped it flourish are a diverse group of innovators full of interesting tales. We hope to share some of said tales here with you today. Thanks again to EOXS for providing this platform. In addition to this show, they are bringing businesses online by providing a standardized digital workspace for all your steel-related needs. Whew, that's always a mouthful. Today we welcome the former manager of the Pre-Source Group at ArcelorMittal, Mr. Eric Batt. Eric, welcome to the EOXS podcast, sir. How are you doing?
Thank you very much. I'm doing amazing. How are you doing, Kevin?
Oh, I'm good. I'm just a little sore. The weather's abruptly shifted up here in the north, so we're all dealing with sudden allergies. It's like 50, and when it was like 19 last week. So there's a little bit of culture shock on our end. But how about you, sir? What neck of the woods are you coming to us from right now?
I am coming to you from beautiful Southfield, Michigan.
Michigan.
One of the suburbs of Detroit. So yes, I know exactly that temperature boom you're seeing. I'm expecting freezing in another couple of days, but yeah.
Freezing. I feel like there's a curse for you guys will have a really solid spring the minute you're able to put together a successful sports franchise. And that is
well, that's not going to happen.
That is my one East Coast barb related to sports that I'm allowed per episode, and so I've used it very quickly.
Well done.
I mean, I wanted to be a wanted to be a Red Wings fan when I was a kid, and so
I grew up on the East Coast, moved to right outside of Chicago. My wife was a lifelong Blackhawks fan. We moved up to Detroit. Our kids all grew up as Red Wings fans, and you just got to go Wings.
Man, well, I shifted from the Jersey Devils to the Rangers just because I like winning. So I have no loyalty.
Sure, you want to win and everything.
Yeah, I mean, hey, look, I stopped rooting for the Patriots when Tom left, so.
I hear you.
I have no friends in sports. All right, but no, we're not here to talk about sports, although I'm sure we could share our numerous opinions on the subject. But we're here to talk to you about you, Eric. So why don't you give our listeners a little bit of a primer for how you found your way to ArcelorMittal, your time there, and some of the. So what is your steel story? Plug the title.
The story starts out. I grew up in a small little log cabin. Not really. It was a small town called New York City. Made it all the way from New York City to Hoboken, New Jersey to go to college.
It's not a huge leap, but
yeah, I got that. Well, I grew up not knowing much about the Midwest.
Yeah.
I really liked chemistry when I was in high school, so I thought chemical engineering would be really good. So I enrolled in chemical engineering in Stevens Institute of Technology. And one of the first classes I had to take involved the distillation tower. I blew it up. That did not seem like an auspicious way to start your career, by blowing up a distillation tower. And I was more interested in why the material failed than what actually the chemical reaction was that was going on inside. So one of my friends told me, you might want to switch to metallurgical engineering. It might be a good choice for you.
I think this
was a very solid career advice.
Really quick, I need to take this moment to plug our previous episode with Mr. Paul Thurber, all about safety standards in the steel industry. Go check it out.
Yes. Good news, I was wearing safety glasses and had the prop. We were inside a hood at the time, so that was good. So I still maintained all my bodily functions at the end of that.
No,
so I switched to metallurgical engineering. Yeah, well, a little bit. They singe a little bit, but it's okay. They grow back eventually, and this is a long time ago. So I switched from chemical engineering to metallurgical, and actually it was materials and metallurgical engineering. And they were really nice and said, we think you might want to do a 5-year program since we're switching majors, and that was cool. So the summer between my 4th and 5th year, there was this little job opening, a little company called Bethlehem Steel.
Okay.
And it was in Indiana, and I didn't exactly know where Indiana was at the time. It's that East Coast kind of bias thing. You kind of know where New York, New Jersey gets a little fuzzy, Chicago, and then it's the West Coast. Anything in between is kind of that gray zone, and it's no fooling if you're from New York.
Up till 7 years ago, when my little sister moved there for college, you couldn't have or stated that she wanted to. She hasn't been out of college. She's still in college. A while ago, she expressed an interest in going there, and then I had to learn where it was. And I'm like, huh, okay. I knew it
So
was
it
near
was one of
lakes
those
or something.
discussions. I hear you though, but it was one of those discussions. I went home and say, "Hey, mom, can I borrow the car?" And she said, "Sure." I said, "I'm driving it to Indiana to go to work for a summer." And she said, "Okay, I guess you're borrowing the car." So went out there, borrowed the car, fell in love with blast furnaces and steel making and all that other good stuff. So it was really great. Went back to Stevens, finished off my undergrad. By the time I was done with that, I was mostly done with my master's. So I graduated way back in 1985. Bethlehem was silly enough to offer me a job, so I went actually back out there at the time. And by the time the other job offers came in, I had already been working for a while, so that was good. So I went out to a place called Burns Harbor, Indiana, just outside of Chicago in Northwest Indiana. Started out there and finished off my master's degree there, and they were kind enough to pay for my graduate school and an MBA. So I did that, and it was a lot of fun. And so I was working out there. So I pulled the bachelor's, a master's of science, an MBA. They put me through Six Sigma and all that good stuff. And the steel industry kind of evolved over time. So Bethlehem was acquired by a company called ISG. ISG was sucked up by Middle, and Middle rolled into ArcelorMittal. So that's kind of the progression of how it all continued onward and upward. In the time, I've worked in steel making, in the plate mill, and cold mill. I've been tech service. They sent me, then after a while, I said, you know what, I want to do something a little broader. And I went into product applications, which is what do we do with the steel? So that got me an opportunity to move up to the Detroit area and work with our customers. And that was a lot of fun. Did that, and that involved some trips to like Japan and Germany and England and stuff like that as you're chasing tools all over the world. So that was kind of fun. Then they said, we're trying to put together some strategic plans. Would you like to be involved with it? I said, well, sure, it sounds like fun. So what products should we make at which of our different plants and things like that? And which products are our customers going to need in the future? So I got involved with that, and they said, great. That sounds like you did pretty good job on that. So I said, well, great, we did this great plan. What are we going to do with it? And they said, what do you mean? I said, well, we put together this really good binder. I think someone's going to ask us if we're going to implement it. So they said, great, you've now got strategic implementation. Congratulations, you have a new job. So the good part was I got to write my own job description, and that was amazing. So I wrote my job description, and I did really well at it, and started putting together a group that basically took the ideas of what do our customers want. And you start off with some demographics like, age trends and things like that, people living in cities or outside of cities, electrification and all that. You mix it in by talking to your customers. And I'm in automotive, so a lot of the guys who build cars. And then we try and figure out what products they're going to need for the next 5 to 7 years. Then I get to take those ideas and run over to research with them. And ArcelorMittal is a pretty big company. We've got like 197,000 employees and a whole bunch of people in research. And so you take it over to some really smart folks who all have PhDs and things like that. And you say, we'd like to make the following products. And they come out of the lab and say, this is what we could come up with. And then you go run back to the customers and say, would you be interested? And hopefully they say yes. And then you take it to our plants and you say, we'd like to make this new thing. And they say, you want to do what? Oh yeah, and we're going to make a lot of money doing it too. And they say, okay, we're in. So you put all that together and you get all those groups talking to each other. And next thing you know, you have some new products to make. And that's kind of what I do.
I want you to know that there's sometimes we get guests that like the process of getting to where you've gotten is not laborious, but it does require a little bit of elbow grease. You are a fountain of wisdom and
I wouldn't go that
information.
far.
For a podcast host, it really makes me happy because I get to stretch a little bit and ask some deeper questions. So thank you for that. But I would love to take it way back towards the beginning a little bit and your first job at Bethel or Bethlehem.
Sure.
Was it Bethel or Bethlehem? I'm sorry.
Bethlehem Steel.
It was Bethlehem Steel,
like
right?
Bethlehem, Pennsylvania.
I couldn't hear you really quick. What was that summer job that you had to borrow the car for? What exactly did it entail? Because it sounds like that was really important in your decision to wanting to continue working with steel. So what were you doing during that time?
So it was absolutely fascinating to me because in school you learn all this theory. And they went out there and they said, well, you know what? You're going to work in a steel mill. So bring out clothes like you're going to dress for that. So I brought out jeans and flannel shirts, and I walk out there and everyone's wearing like collared shirts and ties. So first I run out to buy some new wardrobe, which seemed like a reasonable idea. And then I was actually working with the basic oxygen furnaces and the casters and developing practices for making automotive steels that actually look like you'd want it on a car, because this dates back to switching from ingots to casters and how to make the proper surface using the technology on the continuous casters at the time. So I was out hanging out by furnaces that tap out about 3,200 degrees Fahrenheit and have about 300 tons in them at a time. So that's pretty massive. I mean, if you're going to totally geek out on the technical side, it's a lot of fun.
For our audio list, for our listeners that are not watching this podcast, I just need to tell you that the smile that broke out across Eric's face when he's describing the scale of some of these furnaces it's truly a warm thing. As someone who finds things to be passionate about, it's really nice when you can't help but express that admiration. One thing
I
you
can
just
honestly say I am never bored at work. Sometimes you get frustrated, sometimes other stuff goes on, but I can't ever say I'm going into a day and I'm going to be bored. And I'm really grateful for that.
Well, I think that you're also bringing up problems I've never really heard before, such as like you think of what steel's utility, and that is its primary job as being a useful element to serve a purpose. But you brought up aesthetics a little bit, working in the automotive industry, steels that look good on cars. Could you elaborate on that a little bit?
Sure. Actually, it even gets stranger than that on cars. I've actually run into a case with earth moving equipment, where if
Oh,
you're buying a piece of earth moving equipment, you would say, why would you ever want that to look good? But if you're going to lay out that kind of money in a showroom, you want to see a luster on it before you drive it into that mountain. Same way, if you're going to go out and buy a new car, you're going to go into a showroom and you want that thing to shine. Now, you may never have that level of shine on that car again, but boy, does that look good when you first get it.
yeah,
And that's going to
exactly.
influence you.
It's an incredibly powerful buying tool.
Yeah.
Just because even like years down the line when that mover's seen a ton of wear and tear, that image you had of that first time seeing it is still going to stick in your mind.
And that because of that, you're going to go back and be a repeat buyer.
Yeah, I think people appreciate that. Plus, when you have very similar like statistics on how a mover can move, like assuming you have two like very similar
Sure.
movers in terms of specs, are like horsepower, engine, torque,
Yeah.
all the various things, hydraulics that go into an earth mover, you're going to want the one that looks cooler.
You want it to look cool. You want to be comfortable sitting in it. You want to have a decent stereo system.
Yeah, I want the Batmobile of earth
You got it.
movers.
So why shouldn't we as suppliers do our best to give that to our customers? Because that's going to enable them to sell their product to their customers.
I think that that's really really cool. But it sounds like you're also speaking a lot to something we talk a great deal about on the show, and that's building rapport with customers and learning that process of like, what do they
100%.
want? How can I help them? Was that something you struggled with in the industry, or you seem like a very outgoing guy, so I feel like you might have taken
That
to
may
it.
be a little bit of a learned behavior.
Oh, okay.
So I started out, remember
Fake it till you make
engineering, that engineering side. And then I got really lucky in that both through college and then when I started working, I got exposed to dealing with people. And people are a lot of fun. And that's where you actually learn things. I mean, it's come as a shock for an engineer to say that, but that is indeed how this works. So that having those conversations with people, that leads to our best ideas about what they're actually looking for. Otherwise, you can develop anything you want, the greatest thing in a box, and no one's ever going to be interested in it. So it's got to be from the customer needs. And even if a customer doesn't need it, you have to ask them what are their problems. And from their problems, you can find out their needs because they can't articulate their needs.
I think that providing customers with a ton of information, as an engineer that's used to thinking about a lot of big concepts, have you gotten better at sort of shifting gears a little bit and talking to people as like if they're not engineers, which a great many of us aren't?
You better believe it. It's a learning experience. Luckily, I'm married to a teacher who did a great job in trying to explain to me. I once had to do a class on mechanical properties to one of our customers, and they had gathered up a whole bunch of their employees. And I looked at my wife and I said, this is going to be really hard. How do I describe these really technical concepts to a bunch of people who have never taken an engineering or a materials class before? And I explained it to her and she said, this is the easiest thing ever. It's nice to have a wife who can actually point this stuff out to you. And I said, how do I do it? She said, you get some licorice. I said, okay, explain this to me. She said, well, pulling a tensile, you take a piece of steel, put it between two grips, pull it apart, measure how much force it took to pull it apart and how much it stretched. Hand out a piece of licorice to everybody. Tell them to pull it between their hands, see how much it stretches, and afterwards eat the licorice. She said, you'll have them eating out of your hand in 2 minutes. She's right. I've used that at least a dozen times, and it all works beautifully for explaining a tensile.
I mean, if you feel like if you've informed people and then at the end they have just licorice as a byproduct, I feel like that's just a win-win-win.
You got it. And you got to realize it's all about making sure they have some food and a smile on their face at the end of it.
Okay, to any educators out there, if you incorporate candy in some way, no matter how old or young you're dealing, like the kids you're dealing with, you're gonna see like big dividends on that.
But while it works with kids, it works even better with technical groups and purchasing groups and customers, because kids are used to seeing candy.
That's
you
true.
Want to put a smile on someone's face, you go into a business meeting and pull out a package of Twizzlers. You have their attention.
If my mom happens to be listening to this podcast, I would like it to be said that I don't think I saw enough candy, Mom. So that's just my little chip on my shoulder. But
you throw that on a pitch, and hopefully you'll be able to use that future in your life.
I mean, I do think that that's a really fascinating idea, though. So it sounds like you're very fortunate to have a partner that's helping you and like teaching you.
She's totally amazing. Much props to teachers and anyone who can educate anybody. They are way underappreciated and so deserve it.
So do you think that
as much appreciation as we can?
Do you think that part of your role has become being a teacher and an educator in that way, that you need to bring customers up to speed on certain things?
Definitely. It's not so much bring them up to speed, although that probably is appropriate. It's as much, the steel industry has done a lot of evolving in the last 30 years, 20 years, 10 years, 5 years, 6 months. And as these things change, and the pace of change is increasing rapidly, as they do, you have to find ways to communicate it. So there's a lot of education that goes on. And that's a major part of what I do. Is it's not only educating our customers, but educating our own employees.
Now, I think in the spirit of education, you've remarked on a ton of changes that the industry has undergone since your start in it. What sort of educating have you had to do for yourself? Like, what sort of things have you been forced to change or learn more about, even later on in your career?
Well, one of the things I've learned is you need to keep exposing yourself to new ideas and new areas and new departments. So I started out in the metallurgical department, jumped to quality, left there to go to research and product applications, went from there to sales and marketing. So a desire to keep learning is what keeps you young and keeps your views fresh in what you're doing. Otherwise, you can be stuck in the same job for the rest of your life, and that wouldn't be exciting. As far as what I've learned, the basics are there, but the steels that we're making now it's a very hard time relating them to what I started with this industry. So way back when I started, strong steel was like 50 KSI yield strength. And I'm using English units here. And that's about 350 megapascals. So one of the things you learn is how to switch from English to metric and back and forth. Something that I personally have a challenge with, but it's one of the things you learn to become very frequent.
In your time as an engineer, have you gained a certain loathing towards the American metric system just because it's needlessly complicated and everyone else is using something different?
No, since I'm on the commercial side, I don't loathe either one. I'll talk either way. And I'll go back and forth regardless without expressing any opinion on which one's got an advantage or the other.
The perfect salesman speaking out of both sides.
I will go either way on this one, and it's good with me. But let's say the strongest stuff that was being used to make a car at the time was something like something like the door impact beam. This is the part in a door that if you're driving along and someone T-bones you, it's what saves your legs because it stops the car from intruding and crushing your body. In the front and back, you've got that big engine in front of you and that hood in the back and a whole bunch of things that are designed to crumple. On the side of a car, it's not designed to crumple, it's designed to push you out of the way, and it pushes the whole car. That's a pretty cool idea, but you want something really strong there in case instead of getting hit by something small, a bicycle, a shopping cart, or something like that, you actually got hit by a vehicle. So at the time, that material was like 50 KSI, 350 megapascal, that sort of stuff. Not relatively interesting. Right now, the stuff that's coming that is in those same areas is more in the order of 220 mega KSI or 1500 megapascal. So it's like a factor of 5 stronger that's saving your legs when someone was too busy using their iPhone rather than driving. And those are really important because like I have kids and grandkids and I want them all to survive. So it's really useful having really strong steel in those type of applications. And that's part of where I get to play around and say, what can we do to make it stronger? You know, we can make it, we can build it stronger, all that sort of stuff. We can do it.
So you talked a little bit about the types of metals that you're making now compared to when you started.
Sure.
How like has it been a steady increase of innovation, or was there just one defining moment in the career that sort of exploded into, oh wow, now we have to make a ton of different sorts of materials and components and coatings and all that?
I think that's what people don't understand about the steel industry. They see it as old technology. And it hasn't been. It's been evolving at least throughout my career. And the pace of innovation is increasing. You've got all kinds of things. And even for me to stay current on it is hard. And I don't even know how some of our customers stay current with it, except talking to us and us talking to them.
So I think just because the idea of it, like you said, is really hard to wrap your head around. You're thinking, oh, this is a material that exists in nature. It's in the earth. It's mined, it's refined, and then used for a bunch of different things. So could you give an example of where innovation can creep up or where it has creeped up in your time?
Sure. So here's one that was kind of interesting. We had a customer come to us from the West Coast, and they were actually building railroad cars, something I don't deal with very much right now. And they were taking between 1/4 and 1.5 inch thick plate. So these are really thick plates of steel. And they needed to bend them in a U shape and bend them around a really tight radius. And they couldn't figure out how to do it given the steels that were available at the time. So it went kind of like this. We get a phone call and say, hi, this is so-and-so, purchasing agent from so-and-so, and we need you to make something like this. Okay. So I got a couple of our engineers together. It cost me 3 pizzas and a couple of bottles of soda. Soda, not pop. We sat down and came up with the chemistry and ran it over to our folks who were in the marketing department at the time and said, we think we can come up with something like this. We'd like to go talk to the customer and maybe sell them 300 tons of steel. Okay. The customer decides to come out and visit us in the Midwest. We go out and with the marketing department, we're going out for dinner, and the customer says, yeah, we really like your plan, but you know that 300 tons of steel we want to buy? We want 2,000 tons a month starting next month. That was the look on our customers. That was the look on marketing's face, followed by them saying, we need to order shots. I'm still on the engineering side. So it's like, okay, we're going to give this one a shot. And we trialed it, and I ended up getting several trips out to the West Coast out of that deal, and we made a lot of steel for that application. So that was one of those cases where it's like, that was not a creep up. That was a slam over the head. We got to get this going fast.
I think that's so hilarious for so many reasons. I'm just thinking about the people I hang out with, and it's mainly like combat sports and MMA people, and we'll get rowdy and we'll think we have this new like choke or something, and we'll try it on people, and it's like, it's nonsense. A bunch of engineers in the same scenario. Hey, we think we made a revolution in the steel industry on this napkin with some equations. You might want to sell this for $1 billion.
Yeah, but don't forget the pizza, because the pizza is the thing you needed to make the whole thing work.
Okay, now, but you see, I don't know about that, since you stated you spent some time in Chicago, and I don't know if although you came from New York, I don't know if you've stayed true on the path. Is this some deep dish monstrosity, or is this like flat?
No. flat extra grease
Okay, good.
and
Yeah.
roll it up because and do not wipe the grease off with a napkin. It helps it ease down.
Oh my brother's a bodybuilder, and you always see him like dabbing the thing with a napkin before he eats it. And I'm just like, come on, man.
Well, I used to weigh a lot more than I do now. So
So, like, you've talked about some things that have happened, things you've been a part of. Are there any concepts that are in the works that you're aware of that you're excited about, like directions the steel industry might be taking in the next 5 years in terms of like components and the science behind it?
oh yeah, you're like opening up a candy box here. It's like, which way do you want to go on this one? So I'm trying to figure out which way to go on this one. First of all, the strength levels we talked about. The strength levels continue to progress onward and upward. And now we've devised steels that are stronger than a lot of the end uses or even the equipment to be able to form the steels. And that's one of the things I've gone to talk to people about is, we've done a great job on the steel industry and we continue to do so. But the other thing that you've got to worry about is who's going to process it and how are you going to stamp it and form all these things. The other thing that it's always been a trade-off, one of these things that you can't have your lunch and eat it too, or something like that.
Cake,
But
cake
this,
and eat it too.
that's the one. Well, I'm trying to avoid the cake thing again.
True.
But one of the things that we worked on is how to improve the level of formability while you're still increasing the strength. So in this case, things like press hardened steels, which are actually rolled, and then you heat them up and you stamp them while they're still hot. They have incredible formability while they're hot. And then when they're cool off and when you cool them off quickly, they get really, really strong. So the question is how to be able to balance that strength and the formability, and even better, how do you get both out of them? One of the other things that's going on, especially within ArcelorMittal, is we're an international company. And so we're all over the planet. And the idea of an idea coming up in one area and then being transmitted to another region, because our customers, especially the automotive ones, are global. So they want to be able to have the same materials in different regions. And how do you transfer that technology from one area to another is a little bit of a challenge at times. So that's kind of fun. Overall, the challenge we have is that people don't understand how high tech it is. And that's really one of the images of the steel industry that is really needs some serious work and polishing.
I was gonna say, do you think that there would be a bigger influx of like engineers and high-minded like big thinkers in the steel industry if that was more apparent? Like if the
Oh,
level
definitely.
of techniques and complications in that side of things were more apparent?
Oh, definitely. I think that it's more an image issue than what we actually need. Just finding people is a challenge these days. We have a very experienced workforce and a whole bunch of people retiring. And the newer folks who are coming in have tremendous opportunities up front. So when I started, it was a down cycle in the steel industry. And people were looking at me and saying, "You're crazy. Why would you ever do that?" And I looked at it as, hey, if it comes through and steel is still important, and it is, and I think it still will be, you've got tremendous shot for doing some heavy duty influencing. Whereas if you go into a high tech company, you may be still doing grunt work at a young age and at an older age. Instead, we're open to ideas. And the idea of, it's one of these really bizarre things. By the time I think I was 4 years in, I was the lead technical contact with one of the automotive OEMs. And that's insane. Why would you trust someone that young to, here, go do that? And because of that, you had the opportunity to influence things and make some changes. And as long as you were willing to push beyond what you were comfortable with, people were willing to let you do it.
We're going to kind of wrap things up with a brief talk on digitalization. And Eric, I know you had some opinions on the subject as it pertains to the steel industry. To begin, what role do you think digitalization holds now, and has it grown over the past 10 years since it's really
Well,
been a
it
factor?
has grown, but is still in the infancy stage. We are just beginning to see this kick in. We were talking about the evolution of steels, at least in my career in the last 35 years. The next big wave beyond the strengths and the formability and the surface appearance and all that is digitalization. And people are saying, what, digitalization in the steel industry? Oh yeah, this is where it's going to. So we talked about the product and we talked about communication and things like that, but we didn't so much talk about process. And the process is where digitalization really kicks in. So let me give you an example. We talked about some really high strength steels that we're now making, but the processing parameters for those get tighter and tighter as time goes on. It's a smaller and smaller window that you can drive that truck through. And as the problem gets tighter and tighter, we have to take more information from earlier in the process, feed forward to later parts of the process to be able to make the products. Let me give you the example. We started making a product called dual phase 980. Dual phase 980 is a really strong, really formable grade. And it only came out probably in the less than the last 10 years, probably the last 7 years, it started gaining some popularity. And the deal was you have to come up with some tight mechanical properties, but in order to do it, you need even tighter chemistry that's going into your processing lines. So if you would take those tight chemistries and put them in, you'd still end up failing some of the time. That's really bad from a CO2 point of view. It's really bad from on-time delivery, makes everybody upset. And it's not doing the best job we could. So instead, if you take that information from earlier on in the process, forward feed it into the place where you're going to do the thermal processing on the hot dip coating lines or something like that, you can tighten down the mechanical properties. So what does this mean to our customers? It means we can be more reliable. We can have the deliveries on time. We're not going to have to remake the same product 3 or 4 times to get it to them. And that cuts our energy bills. So it's less expensive for us. And basically for the planet, it means less CO2. So from our point of view, that's kind of the point. That's the evolution that people aren't seeing, how steel is becoming really, really high tech and really important from that point of view. So another quick example. Oh, I'm sorry, you got a question.
No. I was just going to say that I've always felt like the green aspect of the steel industry can be kind of downplayed. I mean, it is the most recyclable material we have.
100%.
And I think that that's like any excess fat from the cow that we could trim off, like in the little bits that we can take from carbon emissions from an already really reusable industry and product, that's really good to hear. It's good to hear
Right.
that there's still improvements to be made and that they're being made.
Well, if not, then I should retire now, because that's what engineers are all about. It's like, we can make it better. We can redesign it and do it better again, and we can keep getting better. So another case we've got is in production scheduling. So this is kind of interesting about which material is going up on which unit which time. So there are rules of thumb, and this, wider to narrower and all that other good stuff. But what our folks on the computer science have done is they've started doing mathematical models of how can you do it even better. And there's actually something called biomimetics. I didn't even know what biomimetics was, but it's modeling ant colonies. And from the model of the ant colony and how the ants move around is how you develop better scheduling systems. Because the ants carrying all those little pieces of food down into their hole are exactly what we need to do when we're lining up which piece of steel runs where. And kind of the other one, just because I'm in commercial and got to get into that once in a while, if we have raw material on the ground, we can actually come up with what could we make out of this and offer it to our customers as what normally would have been downgraded material. We can make prime out of it and sell it to them with shorter lead times. So that's a benefit both to us and our customers. So things like that and use of that digitalization is probably the next big wave we're going to see.
I think that it's really cool to take a brief look into the mindset of an engineer. It's just like when you have that raw material and you immediately think of all the things you can use for it, like the things you can build with it. Does that often happen where you come into a project with a design in mind, or does the material lead to the design, or is it a mixture of both?
It's a mixture, because believe it or not, every now and then when we take a shot at making something, we don't get exactly what we wanted the first time. And you come up with it and say, wow, that is really cool. What could I use it for? It's sort of like building blocks with my granddaughter. All of a sudden she's building something else. I went, oh yeah, we could do that.
Oh man, that's an incredible way to look at things, Eric. And I don't want to take too much of your time, but thank you so much. If there's any other, I know we're probably going to be talking about this a little bit longer, but in terms of digitalization, we've seen a lot more emphasis being put on, not just the production side of things, but also, the marketing of steel, utilizing different platforms and digital spaces to get messages out. going back to some place we were at earlier with the high tech nature of the industry and how little that gets broadcast, do you think that companies should be doing more to utilize social media in those spaces to
100%.
inform people of how much of a technological innovation is always happening in the steel industry?
I think we've seen some innovation in that in the last 10 years, but I think that goes back to the number of people who are attracted to the steel industry and why we need a broader selection, a broader cross section of people in. Because yeah, we have a social media presence as ArcelorMittal, but is it reaching the right people and in the right methods? Still working on it. It's still a work in process. And what we need is people who can help bring that to us and say, you know what? There's a different way of doing that.
Well, I have a master's in marketing if you need me.
Tell you what, we'll talk offline.
Oh, well, I appreciate that, man. But again, I think that we covered a ton today, and we want to save some on the table because obviously we want to have you back, Eric.
Hey,
This has
I'd
been
love
an
it. Let me
incredible
know when.
conversation. I feel smarter just from having sat down with you.
Hey,
You know,
Kevin,
the
it's been a pleasure. I
90% of the
really
reason I
appreciate
took
it.
this job is so I could talk to smart people and hope through osmosis I gain a brain cell or two or some IQ points.
Well, I hope
The
you
minute
find some, and if you find some, let me know. But
I mean, the minute I look at a analog clock and I'm able to tell the time, that'll be when I know it's working.
it's all working.
All right. Well,
Every
Eric,
day we
thank
learn
you.
something new. Keeps us young.
Oh, incredible. Yeah, obviously. And thank you again very
Thank
much
you.
for your time. This has been a wonderful experience for me. And for
Thank you.
you, the listeners and viewers, I would hope, because this has been another incredible episode of EOXS's Stories on Steel. Thanks again to Eric for giving us the time and all the wonderful insights that he has. And remember, whether hot rolled or galvanized, EOXS will provide a marketplace to take any steel business to the online sector. Thank you and good night.